Hello everyone, it's Avondale. Welcome back to another episode of the Lobster Helpers. I'm here today again with Actually as a Lobster Guy, and we're going to take a look at how I was able to tell whether he was moving or not. Now, there's a few things we need to cover before we can explain it, but first I want to talk about why it was actually an issue to animate armor stand that was getting teleported to a creeper. So to show that, I'm going to spawn in a villager right here with a zombie. I'm going to go ahead and teleport that villager around. So we'll TP at E, type equals villager, we'll say a radius of, 15. And we'll just teleport him to me, if I can type. There we go. And you'll see that the zombie is just instantly following him around, and he's always going to pursue this villager no matter where it goes, right? He's never going to stop and think about whether he's pursuing him or not. As soon as the villager moves, the zombie moves. And there's never a period where the zombie will stop when he's not near the villager. Now, I made him stop a little bit further away using the no AI tag, but it's the important thing to realize about the luxury of using a zombie is you can always tell when the zombie is moving, because if he's not within a certain radius of the villager where you've turned his AI off, he's going to be moving. So why is that different with a creeper? Well, if we spawn a creeper in over here, I forgot to put a button down, we'll just spawn in a silent creeper, and what you're going to notice is right now he's on the other side of the thing, so if I go into game mode 2, he's going to end up blowing me up when he pursues me. Let's go back into game mode 1. We'll actually let him out here to show this example. So he's following me right now, right? But if I turn around and I sprint away, I can get out of his range really quickly, and now he's not pursuing me anymore. So the creeper's not really going to pursue anything else but a person, which is why I had him actually follow you. But he has the potential to stop when he's not nearby you. And with the animation I had set up for the zombie, the way that would have worked is I would be looking out right now and I would see Actually as a Lobster Guy by that creeper, and he would still look like he was walking. Obviously, we couldn't have that because that wouldn't make sense. So I needed to figure out a way to teach Minecraft to know whether a creeper was moving or not. This proved to be really difficult, and to do it is I used that silverfish down there. Before we can understand that, however, I need to make sure you guys understand how fill clock works, so we're gonna go talk about that now. Alright, I'm looking at a fill clock right now. You guys see me use these in just about every episode, and the point of the fill clock is it sets a certain area of blocks to redstone block and then back to stone 20 times a second. So the commands for that are sitting here. You have fill relative coordinates, so 1 up in the Y, 10 over in the X. It's filling it with stone on the bottom one. If we do this, you can see that. And then the top one is filling it with redstone blocks afterwards. So you can see that if I do that. Well, you won't see that because there we go. That one was a little slower. It triggers the bottom one here. So if we wanted it to just stay redstone blocks, we could do that. Okay, so let's get it started again. You can see that it's firing over and over again, and we can actually see how quickly that's firing if we just say whatever, we'll say a period. You can see how fast it's firing. If I type something else in chat, you can just watch that scream by. So we'll take that off, we'll clear that stuff off the screen. So how does the fill clock choose what order it's going to do things? You would think initially that it does everything on the strip at the same exact time, but it actually doesn't. It does them in a predefined order. And that order is based on 2 things. The first thing it's based on is X, Y, and Z. It's going to pick the X direction first, the Y direction second, and then the Z direction third, if it has to distinguish, say, what's on one of these redstone blocks. And the second thing it checks for is the direction. So it's going to pick X, it's going to bias towards X first, and it's going to go from negative to positive in all of these. So that means this clock runs from here over in order. And then the second direction is Y, so it would prefer bottom to top next. And then the third thing it would look at is the Z direction, which is that side to this side. So to prove that here, I have 4 command blocks that just have say 1, say 2, say 3, and say 4 in them. And so we can actually show this here. So I'm going to lay these down here. You see 1 comes up, 2, 3, and 4. And you notice how it's coming up in order every single time. Now, I can also prove this to you by reversing them to make sure that it's not a fluke. Put the 1 there, 2 there, 3 there, 4 there. And now you notice in chat that it says 4, 3, 2, 1 over and over. So now you know for sure that it's moving across in this direction. And then we said that it goes from Y next, and it goes from the bottom to top. So there's 1, 2, and then it picks Z after that. So it goes from the negative Z over there to the positive Z over here. And you can see that it is then running in that order. So we know all that. So how do we apply that into our commands? Well, we have the actual clock that runs actually as a lobster guy over here. And I've marked with yellow wool here the different commands that control whether he's walking or not. So certain things had to happen in a certain order. I guess first let's take a look at what actually as a lobster guy does when he's walking. So you can see here he's walking around. You'll notice the silverfish is lagging a little bit behind him when he's walking. This is intentional, and it runs on this clock here. It's just a hopper clock. You have an item going back and forth, and there's a comparator output coming out of it. And every time this fires, it's teleporting C actual S, which is the silverfish, to C actual, which we know is the creeper. So it's only teleporting him once every time the hopper clock fires. And so if I come down here and I go into game mode 2 again, you can see as he pursues me that the silverfish is just trailing after him about a block at a time based on the rate that he's walking. It's pretty easy to watch the silverfish jump around a block at a time. Now, this is instrumental to knowing whether actually as a lobster guy is moving or not. If we go back over to the clock here, we can see what I'm doing. So the first thing that happens every time the clock fires, very first thing, is it's going to set the creeper's score in an objective called still to 0. So it's always going to be set to 0. Now, because these things fire in a tick and the game only updates what happens every tick, it chooses these commands in order. So the first thing it does is it sets it to 0. However, right after that, it's going to execute on that silverfish, and it's going to do a scoreboard command that sets the creeper when it's in a radius of 0 to the silverfish. It's going to set the still score to 1. So now the game, running the clock through in this direction, if the creeper isn't on the silverfish, it's going to think it's 0. But if the creeper is on the silverfish, it's going to think it's 1. You're not going to see any traces of the 0 anywhere in the game when the silverfish is right under the creeper, because this command here is second. And that's very important. The ordering in this is what matters a lot. Now we look at this one here, and this is the final piece of the puzzle. It's an extra objective that I called still count. Now what this is doing is it's checking to see how long the silverfish has been right underneath the creeper. If you just had the animation go to the still animation every time the silverfish was under the creeper, it wouldn't have worked, because it would have looked like the guy was stopping and gliding every, half a second or 3/4 of a second, however fast the hopper clock is. So we needed an extra objective to try to fake the way around that, and this still count as that objective. So if you look here, anytime the score of still is 1 or greater, so it's at least 1, it's going to start adding on this still count objective. So anytime that silverfish is right under the creeper, it's going to start counting that still count. And now over here, it's trying to pose this guy with an entity data command, but it's running this command on the creeper as an execute command, and it's trying to find a creeper with a this creeper with a still count that's at least 7. So if the game detects the silverfish underneath the creeper 7 ticks in a row, it's going to perform entity data on actually as a lobster guy, and it's going to cause him to pose like he's stopped. Now, the one other piece of this puzzle is down here on the bottom. It's setting the still count to 0 for anyone with a still score of 0. So what this does is whenever the creeper gets off from the silverfish, it resets the still counter, so you couldn't have it be still for 3 ticks and then still for another 4 ticks and have it think that it stopped. Or, you know, it adds up 1 tick at a time. Stuff like that I didn't want to happen. So let's go back over here and we'll watch, actually, as a lobster guy walking around with a couple different objectives. The first one is the still score. So you see him walking around. Every time he's moving, it's 0, but it turns to 1 every time the silverfish catches up with him. Let's go to game mode 2 again. You'll notice it's going to 1, back to 0, 1, back to 0, over and over again. But that's not the most important thing, because the most important thing is that additional objective, which is the still count. So here you can see as he's walking around, if we go, we'll go back into game mode 2 here and we'll let him out with us. You can see here that his still count is getting up to about 5 or 6 ticks. That's as long as the game is testing for. That's basically the margin of error that the game has. So you'll notice it never gets up above 7 ticks while he's actually moving. It can never test for that silverfish in that small area for longer than 7 ticks. So he's always moving. Now when he stops, you can see as soon as it hits 7 there, let's watch again, watch that counter on the side and see it hit 7. And as soon as he hits 7, I'll do it one more time, you watch and you'll see his head tilt to the side. Right there. Do it again. Right there. And it'll happen every single time consistently because of that. Now while he's standing here, the still count's just going to go up and up and up until he starts moving again, then it resets back to 0. So that's how I was able to get Minecraft to be smart enough to know whether a mob was moving or not. It does have a slight delay in its accuracy. Right now the accuracy is about 1/4 of a second. It'll be aware of it. You could probably make it go a little bit faster, but honestly, I tried it and it doesn't give a good enough result, and it bugs out a lot more, so it's not really worth it. So yeah, and this mechanic was based on, you know, the zombie and villager mechanic not working for this type of scenario because I needed the creeper to run away. It was necessary because the creeper stops when he's not near you, and then I ended up solving the problem with a creeper and a silverfish. I also explained about fill clocks, and then I showed you guys how the commands work in the actual fill clock over there. This is a pretty complicated thing. Anytime you're running commands that need to be, you know, appropriately ordered on a fill clock, it's going to be pretty complicated to do. So please, please, please ask me questions about this. If I didn't do a good job of explaining anything that I did, ask me the questions, because I really want to help you guys, you know, gain this knowledge. It's something that it's a concept that if you know how to do really well, you can do things that you didn't previously think were possible. And this lobster guy was actually a result of a pretty good brainstorming session with me and a couple other redstoners, just trying to figure out, you know, different ways that you could sense this motion, because it's really difficult to do that without a statistic. So anyways, let me know if you had any questions about today, and whether you do or not, I'll see you next time. I've been Avondale, thanks for watching. I made him stop a little bit further away using the no AI tag, but it's the important thing to realize about the luxury of using a zombie is you can always tell when the zombie is moving, because if he's not within a certain radius of the villager where you've turned his AI off, he's going to be moving. So we'll TP at E, type equals villager, we'll say a radius of, what, 15, and we'll just teleport him to me. If I can type, there we go. And you'll see that the zombie is just instantly following him around, and he's always gonna... Hello everyone, it's Avondale. Welcome back to another episode of the Lobster Helpers. I'm here today again with Actually As a Lobster Guy, and we're going to take a look at how I was able to tell whether he was moving or not. Now, they're gonna pursue this villager no matter where it goes, right? He's never gonna stop and think about whether he's pursuing him or not. As soon as the villager moves, the zombie moves. And there's never a period where the zombie will stop when he's not near the villager. Now, there's a few things we need to cover before we can explain it, but first I want to talk about why it was actually an issue to animate armor stand that was getting teleported to a creeper. So to show that, I'm going to spawn in a villager right here with a zombie. I'm going to go ahead and teleport that villager around.